friends, solar thermal energy. So solar thermal energy. So everyone is telling about solar power stations. So initially they used to tell about the wind energy. Now they are telling that solar energy. But nobody is thinking much about the solar thermal energy. And also, I hope majority of the persons don't know what is solar thermal chimney or thermal chimney. So coming from the starting, so why we have to say this this video, or why we have to do this? We have to make this thing is that there is importance about solar thermal energy. There is something interesting things. See, even up to the PV energy, solar photovoltaic energy. So there is the utility of the turbines. Only when the photovoltaic cells came. So whatever we are saying today, we are saying only about the PV cells. So we are not at all discussing about the solar thermal energy. Okay. See, solar thermal energy is important in today's situation. So it is the thing we can make it, we can generate with a 30% of efficiency. So even the photovoltaic energy. So in solar energy, there are mainly two divisions. So that is thermal and photo. Thermal or non-thermal. So where directly the help of the photons we are able to generate the power or electricity. Yes, that is good. That is very good progress. So without any mechanical part, without a turbine, without any medium or liquid medium for energy, that is good progress. So initially, when you compare with the coal thermal plants, so coal means it is creating so much of pollution that it is emitting so much of flue gases. So people thought if there is something better thing, so they went for hydropower. Okay, it is a good progress, but it is a huge process. So the governments should involve to construct a hydropower project. So it is a difficult task. It's not as easy as a thermal plant. Even then they have tried another option for a nuclear plant. Yes, a nuclear plant is good, but it's very dangerous. So and then they have searched for the option, and they came with the wind energy. That's good, but again they want something more. That is, they went for the solar energy and solar photovoltaic energy. So instead of thermal, the PV cells have become more famous than thermal energy. But still, there is much more we have to focus on the solar thermal energy, because here we are not involving with the utilization of the plastic. So after PV cells has become famous, and they became famous and we started using them so much, and after 6 or 7 years or 8 years we don't know what to do with that panels. The life will be over. So it includes pollution in manufacturing a PV cell, and it is also a disposal problem. Already we are facing a problem, eco problem with e-waste, and we are adding a PV waste for that. We are adding some more solve for that issue. So it is the time now. We have to focus back onto the solar thermal energy, which is much better than, which is much eco-friendly than the photovoltaic cell. Our only eco-friendly thing which competes with the solar thermal energy is hydropower. So first of all, what is solar thermal energy? So instead of using some fuel, nuclear fuel or coal or gas or petrol or diesel or biogas or bio-waste, we burn them and we use that heat energy to heat the water and make it steam, and we will rotate the steam turbine, and that is coupled to the generator, and generator will generate the power. So instead of using some fuel which is not renewable, okay, which is conventional, we can use a renewable source, that is solar energy, that is like wind energy. So these are wind energy and solar energies are renewable sources. We have searched for renewable sources. So we want constant supply of power. So we cannot tolerate even a power shortage, power cut for 5 minutes also. So that is the situation we are living now. So instead of using some sources, instead of depending on the sources which will expire, so it is good to depend on the sources which will never expire. In that thought, we came to the renewable sources, that is wind energy and solar energy. So in the starting stage, we have used the solar thermal energy. So here we are using the sun energy directly for heating this water. So the remaining cases, we are using some coal or gas, all these things to heat the water, which will become steam and which will rotate the turbine. We are using directly the sun's energy and we are heating the water. So there is nothing to burn. There is nothing to use any fuel here. So no fuel cost. And also renewable. And also eco-friendly. So there are different, we have used mirrors, concentrating plates or reflectors and different types in them. And today we'll see a new thing which is called a solar chimney, where we are not using any reflectors or any concentrators or any focused things. So first we'll heat the water with the help of the solar energy, and we will rotate the turbines. If you come to the passive, so there we are not using again any water also, any medium. So just air is the medium there, no water required. There is no concentrating thing, just like how the car gets heated. So like that solar chimney works. So already I have explained you, there are mainly two ways we can utilize the solar energy for generating the power. That is directly using with the help of the PV, photovoltaic cells, solar panels, and indirectly with the help of the concentrators, reflectors, all these things. So we will see how the process has started slowly. You may all think that it is solar energy. New thing, it's not a new thing. It is to the 19th century. Okay. In starting 1866, Auguste Mouchot used a parabolic trough to produce steam for the first solar steam engine. So it's the first time he has shown that with the help of a concentrated trough, we can heat the water and make it as a steam, and we can generate the mechanical power. So that became a first solar steam engine. And earlier they used to heat with the help of the coal or some other fossil fuels. In 1866, there was first patent taken for a solar collector obtained by Alessandro Battaglia. He is from Genoa, Italy. And in 1913, a man called as Frank Schumann finished a 55 HP parabolic solar thermal energy station in Egypt for irrigation. It's a solar thermal station. So some mechanical energy was able to produce. First, he has used it for the irrigation purpose. So whatever we are using wind energy first we have used it for irrigation purpose, for pumping the water. Dams, first we have used it for irrigation purpose. Okay, coal energy, that is different. So dams, wind energy, whatever we are using, we have first utilized it for irrigation. Afterwards, we have started thinking how these things, traditional things, we can utilize for generating the power. So first they have first utilized it for the irrigation purpose. In 1929, the first solar power system using a mirror dish. See, first parabolic trough. Okay. Next, a mirror dish. Some evolution happened. Was built by American scientist Dr. R.H. Good Heart, RH, Good Heart. So this is, so first 1866 a parabolic trough, 1886 patent, solar collector, 1913 they have used for irrigation, 1929 so mirror dish from America, and in 1968 the first concentrated solar plant. They have started the solar plant in Italy. In 1981, so they are able to produce up to 10 megawatts of power. Okay, watts, megawatts, kilowatts, megawatts, gigawatts, like that. The process, step by step, we have increased our generating power. So that happened in Southern California, that's America. So California, so it is a place where you can find more, you can find the sun entire year. Probably they have started, that's the advantage, they have started there. In 1984, the parabolic trough technology of solar energy generating systems began its combined capacity. So now they are able to produce 354 megawatts. So it is slowly they have increased. In 2014, that means just 10 years back, the world's largest solar thermal plant, so which is having a capacity of 392 megawatts. Probably now China has overcome this thing. Maybe China maybe number one now. But its commercial operation has started from 2014. So here in this solar thermal energy, we have two options, that is passive. So that means we are not using any equipment like parabolic troughs, concentrators, reflectors. You are not using. Just there will be some construction where the air itself heats up and it will rotate the turbines. So still so much of development and utilization should be taken in the commercial purpose for this passive thing. That passive thing only, that in that passive thing only, that is the thermal chimney. And next thing, active thing. So this active thing everyone knows. So utilization of different equipment for focusing the solar energy on certain pipe or certain tank or certain bowl to heat the water in that. So they will absorb and they will focus. So what is the basic working principle? That is, mirrors reflect and concentrate sunlight. So they will reflect and they will concentrate at some point where there will be some thing which will have the water in it. So that is how it gets heated and it will become steam. And receivers, so they will receive and convert it to heat energy. So this heat energy, that means that is steam energy, will rotate and we can able to produce the power. So you can observe here. So that is the mirror. So from this solar energy, okay, it is the mirror is collecting the solar energy, and that is diverted to the some place where we may have some medium. Again from our heat exchanger, Again from there, it is that heat is sent to the water, and ultimately it is converted into steam. So this is active process. In passive process, we don't find any heat exchangers or steam or water or any pipes or any mirrors or any collectors or any reflectors. So that is passive method. This is active method. So this steam will rotate the turbine, and turbine is coupled to the generator, and finally we are able to produce the power. So the thermal energy systems, we have three types mainly, where we directly, so that is two tank direct system. So the medium is same thing. The solar thermal energy is stored right in the same heat transfer fluid. So that means only we are using single fluid here. And two tank indirect system will be having other fluid which acts as a exchanger. And single tank, where we are not using any liquid medium, we are going to use a solid, usually silica sand, a solid medium. So a silica sand will absorb the heat very good. So here you can observe. So the parabolic mirrors, so at the center of these parabolic mirrors, we are having the water pipes which carry the water. So whenever they enter into these mirrors, water into the pipes which are attached to these mirrors. So you can observe. So these mirrors are focusing the sun's energy on these pipes, and the water here is getting heated and is, you can observe. So blue color has slowly changed to the red color. So that means the water is converted to steam. So that steam is again. So maybe we have a heat exchanger, or some cases we can directly send that steam to the turbine. So we are having some advantages of using the heat exchanger. So if that water which is heated into steam, if it is going directly to the turbine, so we have to take so many precautions such that it don't contain any different types of salts, all these things, acids, all these things, impurities, pollutants, all these things we have to take into care, and after that we can. So if we are having that heat exchanger, we can avoid this, and we can increase the life of the turbine. So afterwards, in the heat exchanger, the heat is absorbed, and then the fluid in the heat exchanger will rotate the fluid from the heat exchanger, will rotate the turbine, and turbine is connected, linked. You can see this. It is coupled to the generator, and we are able to. So after the exhausted fluid, again we will condense with the help of the cooling tower, and again we can utilize. So in that, so many progress. So there is two tank storage system. Again, heat exchanger we can use sometimes. So this heat exchanger, we can store some energy here, like that. Here you can observe. See, there is a big construction over some acres, and around this tank there are so many reflectors. So with this type of arrangement, there is no need of tracking of solar energy. even the sun changes its positions, we can have some place it has to fall, and that place there are reflectors, and these reflectors focus their solar energy on this tank, and it will work. And solar dish system is which is having very good efficiency up to 31 to 32%, and the fluid there we can have with the temperature of 250 to 700 degrees centigrade. We are using in the Stirling engine to generate. Okay, so here we are using the standalone parabolic reflector. Okay, so into a receiver pistoned at the reflector's focal point, we can observe in the diagram. So this is some advanced technology. So this is normal reflector. So drives will be having power conversion unit, mirror, facets, pedestal. The same thing you can observe. These are all consists of solar thermal energy, comes under solar thermal energy. And linear Fresnel reflector, so which increases 30 times. The specialty of using this linear Fresnel reflector is that it is having a capacity of increasing the solar energy, maximizing or multiplying to the 30 times than the normal intensity of that sun's energy. So this is a good thing. So their construction will be like a long segments, and they will reflect, and concentrated energy is transferred through the absorber into some thermal. So ultimately medium will be the some fluid, majority of the cases. Very only in the single tank system where we are using a solid silica sand, that is very rare. And so we'll focus this, we'll receive, we'll focus on the water and make it into some fluid, and we will send that fluid energy to the turbine. You can observe here. So this is how this linear Fresnel reflectors works. See, so we are sending water there. These are the reflectors. So they are reflecting onto the pipes. So water which have entered at these pipes will be heated and soon becomes as a steam, and this steam energy will rotate. You can observe the turbine here, steam turbine, and it is coupled to the generator, and again ultimately it is sent to the transmission lines. So this is a compact linear Fresnel reflector. This is the original photo. So see, this will reflect at this point, and the water or fluid, it will get heated and sent to that steam is sent to the steam turbine. So another method is usage of the enclosed parabolic trough. So it will be like a greenhouse, like glass house, and it is good, it is reliable and having some good efficiency. And you can see it is a single axis system, and here the mirrors concentrate the sunlight, same thing anywhere what. So there we are going to reflect, directly reflect there is nothing arrangement like greenhouse. You can observe. So they are absorbing and they are reflecting. Again, there is a greenhouse type. There is another mirror like structure above this concentrated. So that means it will again reflect back, which is going to escape from this parabolic trough. So there is some greenhouse effect added here, so which is reliable. So these are majorly different types of things we are using. So why we should use this solar thermal energy? First thing is we are not using any fuel, so there is no fuel cost, and we can predict the availability of the sun throughout the year, and there is no problem of pollution or global warming. So we are only using with the existing industrial base, and major thing is we are not using any plastic here, no plastic. So in PV cells we have to use. So there will be a pollution in the manufacturing process, and again it is a problem for disposal of the plastic. Everybody knows it well. So what are the disadvantages of this solar thermal thing is that it is highly costly. So that's why all the multinational companies, they are moving to the photo PV cells. And the future technology has a high probability of making concentrated solar power. So there are some ecological and cultural issues. So it is having some limitations of locations and size limitations. So you can observe we are using very large structures. So if you see here, you can observe. So this is a place, very large structure, more area, and output is less. Okay. So here also you can see the reflector, and only this part we are able to heat. Limited. So here also you can see. These are the Fresnel reflectors. So only one pipe. These are all the things combined doing work is, what is the work they are doing is, only at one small line they are able to make the work. So we are wasting so much of area. Here also. So you can observe here, small pipes. So this entire structure helping to heat the water in only a small pipe, at least minimum of 10% in the size. So that is a size limitation is a big thing. So long gestation time leading to cost. So we need a gestation time. And also we have challenges. So installation cost, energy storage. Storing the energy is a problem, which is common for PV also, or wind energy. So cost should be fair. Okay. And when you compare with fossil fuels, it is costly. Still, we are at so much of distance. So water storage, we need water storage for these things. So much of water we are using. So that is another problem. So we can use phase change materials or thermochemical materials for future development. Thermochemical material for the future. So we can use that latent heat, all these things. So thermal chimney, it is a passive thing. This is further development in this solar thermal. So they are passive already we have. So they are made up of halo, black halo structure. So where the air is hot air will be the medium which absorbs the heat. Okay. So there will be a inlet and outlet. The inlet openings are smaller. When our outlet will be exhaust outlets are placed at low to medium height in a room. So if you see the diagram, you can easily understand. So it is common thing whenever the air gets heated, it will move up. Okay, that's how cyclones normally will come. So the heated air at equator, near to the equator, the air gets heated fast and it will move up. It becomes lighter, it will move up, and the heavy air will fill that place, bringing so much of water along in it. Okay, water vapor along in it, or clouds, resulting to the heavy rainfalls. So similarly here also, whenever this, because of the structure of this chimney structure, whenever the air inside the structure gets heated, it will tries to move up and move out from this chimney. In this process, it will gain some energy from momentum from that heat, and it will rotate. That will rotate the turbine. So if you compare, it has to develop much more. You can see. So here you can. This is one type of thermal chimney. You can observe here. So this acts as the place around this tower is acting like a collector. You can observe. This is concentrated and it is having height. Escape the heat energy. So here you can observe more area and solar energy is falling around it. Right. So naturally the air below this area gets heated fastly, and also it is working like some greenhouse effect also. So they want to escape through the outlet, and at that points you can observe here we are having the turbines. So in that their way to escape will keep the turbines, and these turbines will rotate. And this is a world starting early days they have tried using this chimney, and this is on the advantage is we can also have a PV panels around it instead of wasting that large area. So this is hot air, the air getting heated. Here at this point we are having PV panels, hot air, and the heated air want to escape through this way, and in the middle of that way we are having a turbine, and they will rotate the turbine in the escaping process. And there are some measurements. So how much should be the radius, all these things. We have to take those into consideration. So here directly you can see. So hot air, cool air is entering here, and after it's getting heated, it won't escape. So on the way to their escape, there is turbine, and this turbine is connected to generator, and we can generate the power. That power is very less when compared to the active. That's why we are telling active solar thermal energy. This is passive. Okay, these are not still developed commercially. They are in the process. They are on the way. So at present they are in the demonstration level. So because the temperature is very low, so the potential is somewhat less, and also we need a large space. Okay, remaining the working process already we have explained. Okay, so finally, the importance of this usage of solar thermal energy is that still we are dependent on the oil, all these things for power. So, and population is increasing and utilization is increasing. So, for this purpose, we have to concentrate much on the renewable energy sources, especially on the solar power and solar thermal energy, and active and passive solar thermal energies. Thank you for listening. So, this class will give the idea. So, what is the future scope of solar thermal energy? So, if it is in active solar thermal energy, we can go for some thermochemicals to increase the furthermore efficiency. And another option is passive thing. And now it is at the demonstration. All these things we have to do, especially solar thermal energy, because of the environmental problem and demand, present day demand. And PV cells, in the PV cells we are using much plastic. So in order to avoid that, we have to focus on the solar thermal energy, increasing the efficiency of the solar thermal energy, increasing the utilization of the solar thermal energy. Thank you for listening. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.